All right, good morning, Belmont High School POE. Mr. Sawe here. I wanted to put together one more quick video to help hopefully support your understanding of circuitry, both series and parallel circuits. So please follow along. Hopefully I'm able to share some tidbits of information that are helpful if you struggled on the lab. First thing I want to point out is we have our power supply right here. Okay. And sorry that's dark. Lighting's not so much professional here in my classroom. But first of all, we want to make sure both knobs are turned as far to the left as possible. Okay? And we want to make sure it's off. When we turn this on, we'll see numerical values. You want to turn the top knob all the way to the right. Okay? And then we're going to adjust the voltage to 9 volts, 9.0. That's what it should look like. Okay? You could go ahead and turn yours off. I'm going to leave mine on. Here's our circuit. Give our camera just a minute to get dialed in here. Used to the surroundings. While that happens, I'm going to grab what we need. Let's build a series circuit first. So I need one 330 resistor. 330 means it is orange brown. I'm going to put that there. I'm going to start with one bulb or one LED. Put that there. I need banana clips to hook to the actual power supply that look like this. These are the two ends. And I need 2 wires. A red. And black. I'm going to go ahead and hook those up. Black goes to the negative on the board. Red goes to positive. Make sure they're pushed in all the way, but don't shove them too far so you don't want to bend them or break them. And I need a push button. Probably already figured it out, but be careful with the buttons. The prongs are very sharp. Alright, so if I'm wiring the first circuit, think of it this way. The path of travel for the electricity has to come in the positive, okay, to the resistor, to the button, out the button, to the bulb, and then the bulb has to go to the negative, okay, to complete it. And again, these all line up in columns and in rows. So if you have something out of place, it won't work. For example, I'm going to take my resistor, put it in the positive, in line with the positive power coming in. I'm going to line it up with the button right here. And then I'm going to take my bulb. As you look at your LEDs, the positive terminal on the bulb is the side that's the longest. Okay, that may not be clear sometimes, like this one's bent up enough it's hard to tell. A great way to tell is when you plug it in, and push the button. If it doesn't light up, then it might be the wrong way or it might be a bad bulb. If it lights up red, that could mean that you have the polarity switched. For example, I push the button. It's hard for you to tell. That's red. So if I switch it, the polarity, and have it going the correct way, it should now light up green. Okay? Now, if you're pushing the button and nothing's happening, something in the circuit is not lined up with the next component, either in the rows or in the columns. For example, if I have this bulb leg moved over just one spot, you can see how that bulb leg is not lined up with any of the other components. It comes over here. Well, the button's way up here. So when I push the button, I get nothing. My circuit is not completed. So all the components have to line up. If I move it to line up in the right spot, okay, the light lights up. The lab then asks you to take measurements. You cannot measure the current because, one, our multimeters are not accurate enough. Okay, they're not fancy enough. And two, the current is so small it's hard to measure. So use a current of 0.02 amps or 20 milliamps as your consistent total current. Your multimeter or your voltmeter needs to go to 20. Okay? And now as I measure, if I'm measuring the voltage across the bulb, when the button's not pushed, I'll get nothing. I should get 0. However, that's because there's no power to the circuit. When I push the button, I should get a voltage value. As you can see, I'm getting around 2.1 if I can hold these steady. Okay, that means when that button's pushed, of the 9 volts, that bulb is taking up 2.1 volts. Now, if I come over and I measure across the resistor, when that button's pushed, you can see that the resistor is getting around 5.7. Okay, if I add those up, it should be close to 9. So that's the series circuit. They have you put then 2 bulbs in series. So this bulb will still be in line with the switch, but it'll come down here somewhere. Okay, like so. And then we'll grab another bulb, put it in line, and you'll be able to see that now these are in series. Okay, and as I push, I have my polarity wrong because that was red. You can see that they're in series because now the current goes from the positive to the resistor, through the resistor, to the button, out the button, to this bulb, across this bulb, to the next bulb, and completing the circuit. So when I push the button, okay, both bulbs come on. That's series. If they were in parallel, then the single bulb would complete the circuit. Right? And the second bulb would complete the circuit. Okay, now there's 2 paths of travel for the electricity. From the positive through the resistor to the button through the first bulb, or the current can also travel through the second bulb. Okay? So that's a parallel circuit, and then they have you do a combo circuit. Hopefully this makes more sense. Again, you can't check your voltage readings across the components like this unless the button's pushed. Then you'll have a value. Okay? Any other questions, let me know. It's really important to understand circuits, so hopefully this has been helpful. Again, it's all about making sure your circuit is complete and one of your legs of your components isn't out of place, because if it's just one square over and doesn't line up in the vertical or horizontal, it's not going to work. Let me know if you have any questions. Hopefully you guys and gals are enjoying these labs. Gives you a little break from the worksheets as well, and it gets you more active than what IED did, so you're able to apply what you're learning instead of just doing pointless calculation after pointless calculation. Look forward to hearing from you. Keep up the good work and keep plugging away. See ya.